The goal of this short video is to help you get started with the shell assignment. As you know, shell assignment is a challenging assignment that requires you to plan and execute a bigger programming project, which may have many components. So in brief, you're going to program a shell, which is a command line interpreter. You read a command, interpret a command, and execute a command. Now, in that process, what we need to do is to read a command and find the tokens that make up the command, and then create the command, and then execute the command. So we'll do these three stages in three different modules. We'll do a lexical analyzer in reading the command and creating tokens, and a syntactical analyzer in interpreting the command. In other words, that just breaking the command into components, and then executing the command based on the command type. So we're going to do three main things: ishlex.c, and ishsing.c, and ish.c. So the purpose of the assignment is to build this shell, and in the process you're going to learn the Linux processes, low-level input-output, and signals. The time to complete this assignment is about 26 hours. So it's important to get started early and break it up into components to complete the assignment. So let's think about ishlex in the first place. So you want to start working on ishlex first. That is to define a module ishlex.c, which contains a main program that does the following. Main program receives a input line from standard in. It reads the line and interprets the line and break it into tokens and print to standard out. We will continue in this program in a while loop until no more lines to process. Now, you may want to think about designing a token module to help with creating, printing, and freeing tokens, because the goal of the first module is to get a line of input, break it up into tokens using some sort of a DFA abstraction, and print these tokens to the output, to the standard out. And as you create tokens or print tokens or free tokens, so it's helpful to have some token module to do that. You can also think about another module like lexical analyzer that will take a line of input and use the DFA abstraction to pass the line of tokens. So essentially, you would probably need about three modules: ishlex.c, and a token.c, and maybe perhaps a lexical analyzer.c. You can name them any way you like, but make sure that you break it up into reasonable functions within each one. So what we're going to do is to see, once you develop this component, how that should look like. So I'm going to show you a demo of how a properly designed ishlex should. Now let's take a look at how a properly constructed ishlex program should work. Now clearly you're going to have to think about how to compile your code using GCC 217, ishlex.c, and other modules that you would define. For example, a token module, maybe a lexical analyzer module, and all that. So let's assume that we have compiled them to build a program called ishlex. So this is the first part of the thing you want to do. So ishlex is your shell right now, and it can only do very simple things. It can take a line of standard in and then break them into tokens. So let's see how it works. So you get the shell prompt. Now this shell is incomplete. This is just stage 1. So what we're going to do is we're going to give a line of input, cd, directory 1, directory 2. So obviously I will get 3 tokens out of the thing. And notice that all tokens are named ordinary tokens. That means they are just tokens. But what's a special token? Let's suppose I type something like this. pwd forward file 1. Now this means print the present working directory and forward that output to file 1. Now notice in this case, our tokens are 2 ordinary tokens, pwd and file 1, and one special token. Let's assume that we type an incomplete token, something like this. Now that should give us an ishlex error message that says it's an unmatched court. Same thing will happen if you do something like this. So that's an unmatched court too. So, but if you provide something of this sort, it would properly process these tokens. Now, as you can see, your DFA is going to take care of this matching and find cases where the tokens are error tokens. And so this is really your shell in stage one. After you complete this, this is how your shell is going to look like. To exit from the shell, notice we have a prompt here. You press Control D, that'll get you out of the shell. Now let's think about the stage two of this program. In other words, you're going to now expand your lexical analyzer to create a syntactical analyzer called asgt. So we want to define a module called asgt with a main program that does the following. It receives a line of input from standard in, interpret the line and create an array of tokens, which can be done by using your lexical analyzer, and pass the token array to create a command. A command will contain a command name, command arguments, command input, command output. We will continue in a while loop until no more lines to process. Once again, you may want to think about designing a syntactical analyzer module that will help with passing an array of tokens. So if you assume that your lexical analyzer will give you an array of tokens, your syntactical analyzer will have to pass this array of tokens and create a command. Because of that, you may want to think about a command module that can help create, free, construct, or execute a command, because this command module would be useful in your next part of the assignment, which is ish.c. If you create a command module, then you can also process different types of commands. So you can have functions that can process a cd command or exit command or set environment command or built-in command. So essentially, modularization is important. You minimally have ish-syn, perhaps a syntactical analyzer recommended, and a command module to support with the command, and proceed. And once you create this ish-syn, we'll take a look at how a demo of how a properly designed ish-syn should work. So let's think about how we compile this part of the code. If you think about what you have done so far, you have done a lexical analyzer, you have the ishlex.c, perhaps a token.c. Now, all of those things may be useful going forward. And also we have always used dynamic array.c. So you'll have to include them in compiling your programs. So in this part, in the syntactical analyzer, you may have created ish-syn.c and maybe syntactical analyzer.c and perhaps a command.c. So what you need to think about is to put it all together to create an executable called ish-syn, which is our shell after the stage 2. This is a shell that can take a line of standard in and create a command. All right, let's see how it works. So we type ish-syn, it goes into a shell prompt. So if I type cd dir1, dir2, it would create, say, command name is cd, command arguments are dir1 and dir2. Note that at this point, it doesn't know that this is an illegal command. Only when we try to execute this command, we realize that it's an illegal command. Now, if you type something like this, pwd file1, it will say command name is pwd. Because of this symbol, we know it's a redirection to standard out. So command standard out may be file1. Like I said, your command module may have command name, command arguments, 0 or more arguments, and command standard out and command standard in. Now, if you create an illegal command such as this, at this point, it should know that this command, perhaps it's an input redirection without a file name. So we need to have a file name. So we can recognize a bad command in something like this at this stage itself. So now if you type something like some command with file 1, with file 2, in this case, we would assume that a properly parsed command would give me command name to be cd and standard output to be file 1 and standard input to be file 2. Let's see what happens. So it did the command name is cd, command standard in is file 2, command standard out is file 1. If you create an invalid command, so suppose we have this format here, that is an invalid command. At this point, we must print the error message that it's multiple redirection of standard output. So note that we can recognize at this level some of the illegal commands that has, for example, multiple redirection.